need to wrap a synchronous function for async use in FastMCP without rewriting the entire implementation. You'll see how to create a decorator that automatically converts any sync function into an async-compatible version using asyncer.asyncify. This pattern lets you keep existing synchronous code while making it work seamlessly with FastMCP's async-first architecture, all with just a few lines of reusable decorator code.
Import asyncer. Import functools. From typing import callable, param-spec, type var awaitable. P equals param-spec, P. R equals type var, R. Def make async background, FN, callable PR, callable P awaitable R. At functools wraps, FN. Async def wrapper asterisk args, P args asterisk asterisk quargs, P quargs R. Return await asyncer, asyncify FN, asterisk args asterisk asterisk quargs. Return wrapper.
This demonstrates the async wrapper pattern, a technique for converting synchronous functions into asynchronous ones without modifying their original implementation. The pattern creates a transparent bridge between blocking and non-blocking code, allowing synchronous functions to participate in async workflows. What makes this distinctive is its ability to preserve the original function's signature and behavior while adding async compatibility. The pattern works by intercepting calls to the synchronous function and executing them in a separate thread or process, then wrapping the result in an awaitable future. This maintains clean separation of concerns. Your business logic stays purely synchronous, while the wrapper handles the async integration. The approach leverages Python's type system to ensure the wrapped function maintains identical type signatures, making it interchangeable with native async functions. This matters because it solves the common problem of integrating legacy or CPU-bound synchronous code into modern async frameworks. Instead of rewriting entire code bases or creating blocking bottlenecks, you can incrementally adopt async patterns. The trade-off is slight overhead from thread switching, but the benefit is seamless interoperability between sync and async components in your architecture. Let's break it down line by line.
Import asyncer.
Imports asyncer, a library that bridges synchronous functions into async contexts. It enables wrapping blocking I/O operations for use in async code without thread pools, eliminating common async await integration pain points.
Import functools.
Imports functools for the wraps decorator, which preserves the original function's metadata when creating wrapper functions. This maintains the docstring, name, and other attributes, ensuring proper introspection and debugging in the async wrapper.
From typing import callable, param-spec, type var awaitable.
These typing imports enable precise function type annotations. Callable defines the function signature, param-spec preserves parameter types for decorators, and type var with awaitable handles async return types. This ensures the decorator maintains full type safety when converting sync functions to async.
P equals param-spec, P.
This defines a param-spec to preserve the original function's parameter types. It captures the parameter signature of any decorated function, enabling perfect type hints in the async wrapper. Critical for maintaining type safety when transforming sync functions to async.
R equals type var, R.
This declares a type variable R to represent the return type of the decorated function. It enables static type checkers to track and validate return types through the async wrapper, preserving type safety when converting sync functions to async.
Def make async background, FN, callable PR, callable P awaitable R.
This defines a decorator that converts synchronous functions into async callable background tasks. The type signature preserves the original function's parameters while guaranteeing it returns an awaitable, enabling seamless integration with async workflows without modifying the original implementation.
At FuncTools wraps FN. Async def wrapper *args. P args **quargs. P quargs R.
This is the Decorator wrapper pattern. At FuncTools, wraps FN preserves the original function's metadata, name, docstring, and annotations, so debugging and introspection tools work correctly. The async def wrapper transforms the synchronous function into an async-compatible version while maintaining the original signature through P and R type parameters.
Return await asyncer. Asyncify FN. *args **quargs.
This converts the synchronous function, FN, into an awaitable coroutine using async-compatible. The wrapper preserves the original function's behavior while enabling async compatibility, critical for integrating blocking code into async workflows without thread pool overhead.
Return wrapper.
This returns the decorated wrapper function, completing the decorator pattern. The wrapper transforms the synchronous function into an async-callable version while preserving the original function's metadata through FuncTools, wraps. This enables seamless async integration without modifying the original function's signature or behavior. Async wrapper pattern. The MakeAsync background decorator transforms synchronous functions into non-blocking async tools, preserving their original signatures while offloading execution to thread pools. The decorator order matters. Apply at MakeAsync background before at MCP tool to maintain proper type hints and schema generation. This pattern bridges CPU-bound work with FastMCP's async-first architecture without rewriting existing logic.
The thread that hides itself becomes the event loop's shadow.